So I got like 9 minutes till quitting time. May as well try and do this. So my suggestion here off the side is try that Y1, Y2 thingy. But, if you have any numerical sense to you, it just makes sense to think numerically. Now, let's let x be 0. Well, this would be 3 to the 0, which is 1. And if we did it on the other side, we have 2 to the 0, which is 1, 2. They match, right? Now, if x hits 1, suddenly this guy becomes 3, and this guy becomes 2. Well, obviously something's happening. All right, think about negative exponents. This becomes 3 to the negative first, which is a third, and this becomes 2 to the negative first, which is a half. And suddenly, we start having situations where the left is smaller than the right. So the correct answer is, as long as we're less than 0, this thing is golden. And that would either look like set builder notation, something like that, or negative infinity to 0, depending on who wrote this test. And it wasn't me. At least I didn't write this particular question. Now, if you talk about the whole Y1, Y2 thing, that might actually be a little hard to see on a TI-84. And of course, there's algebra too. I could do some algebra with you. But I don't think you would appreciate the algebra at all. I really don't. So we're just going to throw 3 to the x in Y1. And we shall throw 2 to the x in Y2. And then we'll just look at the graphs with zoom 6. So this will be my 3 to the x. And in red is going to be my 2 to the x. And I should start seeing, yeah, it's kind of hard to tell. Maybe you can kind of, if I zoom in for you, watch this, zoom in. Let's center at the origin. Maybe you can get a better, closer look of it. And maybe you'll see that the blue line is actually underneath the red line, and that happens at x equals 0. You see it? So there you go. That's another way of doing this thing. When I looked at it, I just thought numbers. I thought the algebra too. The algebra is not bad, but it's algebra. All right, find the slope of the line passing through the following points. And everybody should know the formula for slope. Shame if you don't. The shame part is that somehow you're going to leave the school with a diploma. That's the real problem. That is a problem. Anyways, x1, y1, there's a formula for slope, x2, y2. So we'd have 3 minus x sitting pretty over 1 over x minus a half. And boy, that is hideous looking, isn't it? So the two denominators of the denominator are x and 2. And this is actually something that we call a nested fraction, because it is a nest of fractions. It's literally a fraction with more fractions in it. And once upon a time, when I used to be able to teach this stuff before they decided that it was too hard for our children, I would teach this technique. And that is to multiply every single thing by 2x, because that is the LCD between these denominators. So we're going to 2x this piece, and we're going to 2x that piece and that piece. So I'm going to have 2x times 3 minus x up top. Down low, I'm going to have 2x times 1 over x minus 2x times that 1/2. Now, 2x times 3 minus x, last I checked, is something like 6x minus 2x squared. Down low, x's cancel. I have a 2. 2 times 1 is 2. 2's cancel, minus an x. And that's all you can do with it. That's what it says. So there you go. Hip hip hooray. All right, 37. Assume that A, B, C, D, and E are natural numbers. Determine the number of positive real zeros which the polynomial function f of x equals ax to the fifth minus bx to the fourth minus cx cubed plus dx minus e might have. So my suggestion here is to Google Descartes' rule of signs, and I'm just going to assume you're not going to do that, so I'm just going to do exactly what I told you to do. We're going to Google Descartes' rule of signs. And let's do a little scrolling here. I like purple math. What is Descartes' rule of signs? How does it work? All right. Use Descartes' rule of signs, determine the number of real zeros, not what I want. I want positive, right? So first, look at the polynomial as it stands, not changing the sign on x. This is the positive root case. And what we're going to do is we're going to look at signs and see how they change. So in this example, we have a positive, then a negative, then a positive, a negative, a positive. We count sign changes. Positive, negative is one sign change. Negative, positive is two sign changes. No sign change. Another sign change makes 3. Another sign change makes 4. You can kind of see how they've drawn this. 1, 2, 3, 4 sign changes means that she has 4 positive roots. So now let's go back to my example here. We are going from positive to negative. That's a sign change. A negative to a negative is not a sign change. A negative to a positive is a sign change. And a positive to a negative is a sign change. Therefore, because there were 3 sign changes, there are 3 positive real zeros, at least possible. That's Descartes. All right, select from the following numbers the one which is not a possible rational zero, or select from the following numbers the one which is not a possible rational zero of the polynomial function. And I'm not going to show you the answer choices here. I'm going to show you the list of possible. Your possible list is your factors of the constant, which is 6, which is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, sitting pretty over factors of 4a, which is plus or minus 1, plus or minus 2, plus or minus 4. Then you make a list. You go through and you take every single number, you divide it by 1. You get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Then you divide by 2, plus or minus a half, plus or minus 1, plus or minus 3/2, plus or minus 3/4. Sorry, I'm supposed to be moving on. That's the 3 over 2. 6 over 2 is 3, plus or minus 3. Every once in a while I get disoriented. It just happened to me. So now I go through and I divide by the 4. 1 over 4 is a quarter. That's going to be new. 2 over 4 is a half, not new. 3 over 4 is new. And 6 over 4 is 3 over 2, so not new. This is your list. The correct answer to this question does not lie in that list. And the last one, and that was the teacher bell, so I'm free to go. Determine the sum of the solution. So I'm an algebra teacher, so I'm going to show you y1, y2. I'm also going to show you the algebra. First thing I'm going to do is isolate. Make that the absolute value of 2x plus 3 is equal to 5x plus 5. All right. Now, I'm going to write 2 equations. The first one is as is. The second one, we change the sign on the stuff inside. Some of you guys grasped that. Way too many of you did not. And you're probably not going to be the ones watching this video. Very few of you actually will. And that's just the reality of education today. It's really sad. It makes me want to not teach anymore. That's the truth. So we take away 2x from 5x and we get 3x. Let's go ahead and shift our numbers over. 3 minus 5 is negative 2. So here is an x value. X is negative 2 over 3. All right, there's one of them. The other guy, let's just shift my x's right. That'll keep them positive. 5x plus 2x is 7x, if I can write. And then negative 3 minus 5 is negative 8. And that would be that x is negative 8/7. And they wanted the sum of the solutions, so you're supposed to go back to 5th grade. And preferably you do this by hand. The least common denominator between 3 and 7 is 21. It has always been 21. Negative 2/3 is negative 14/21. And negative 8/7 would be a negative 24/21. And then we just put like terms together. Negative 14, negative 24. I believe that's negative 38 over 21. And that's how I do it. Now, I said I would do this in a TI-84. You can always put the left-hand side into y1 and the right-hand side into y2 and do intersections. Now, this was a math contest. test. That's where it came from. It came from a math contest that we go to every spring. Math, no, maybe yes. 2x plus 3. I'm going to put the left-hand side in y1 and the right-hand side in y2. Right-hand side being 5x plus 2. I'll do a zoom 6 like I trained you, and if it's not good enough, I'll play with the window. And it's actually possible that my algebra doesn't work because, and I talked about this, things happen. This didn't have two answers now, did she? She did not have two answers. Look at that graph. I remember talking about this. Algebra will sometimes show you the wrong thing. Only a graph can show you the real thing. So that algebra I didn't work. It did not work. Maybe I made a mistake. I'm too tired to check it. But it only has one answer. So the one answer is going to be the correct choice. So second, trace 5. Enter, enter, enter. And there she is, negative 0.66667. So algebra gave me two answers. This one is nothing. And since that is the only answer, that is the sum of the solutions. There you go, kids. There's your bonuses. You're welcome. You'll still miss them.